today in this video, we're going to understand about precision recall curve. We know what is precision and recall as an individual evaluation metrics is when we speak about the classification model performances. But what happens in precision recall curve, or in short, what we call it as PR curve, is you're going to evaluate the model performance by evaluating or testing it as a different thresholds. That is, you're going to have a graphical representation where you're going to plot your recall versus your precision by evaluating the model performance at different thresholds. At different thresholds. We all know that it is the default threshold what is set as 0.05. If the sigmoidal conversion value, if it is coming out to be greater than or equal to 0.05, it will be put into or classified into positive or true classes. If it is less than the threshold value, it will be put into negative or the false classes. But what if you want to evaluate the model at different thresholds like 0.3, 0.4, 0.7, plus you want to evaluate how model is behaving with different thresholds, is what you can understand as an insight of PR curve. So obviously for us to draw a PR curve, we need P and R, that is precision and recall, where precision is going to tell us what is the true positive rate by considering the model of predictions. And recall is going to tell us how much true positive that model predicted by considering the actual positive data. That is, recall is going to give us a perception of how many true positives are there by considering the actual true positives that we have in our data. But recall is going to tell us how many true positive model predicted correctly by considering the model predictions. That is by considering the default clusters involving true positives and true negatives too. That is how we are going to draw an PR curve, where in x-axis you're going to have your recall ranging from 0 to 1. On y-axis is precision ranging from 0 to 1. That is how you're going to get a graph, something like this, where you're going to have recall on x-axis and precision on y-axis. This graph illustrates the trade-off between your precision and recall at different threshold levels. How it is happening, we'll just see and understand with a small implementation. So for implementing, I've taken a small value that is the actual labels, where I've labeled it as y true. And where I have the predicted value, here I have not taken the actual labels. Rather, I have limited myself to the range of probabilities. Why range of probabilities or the sigmoidal conversion value is taken is it is easy for the model to evaluate at different thresholds if we have the range of probability values. So we have taken both our actual labels and the predicted labels and giving it to the precision recall curve. What will precision recall curve will do is it's going to plot your precision and recall by evaluating at different thresholds. So whatever the values that we have got, we are giving it to the precision recall display. That is what will give us this curve for us. That is what is going to give us this curve, where on x-axis you have your recall and on your y-axis you have your precision. You can see both your precision as well as recall is higher, is 1 till you reach the threshold of 0.8. That is for an ideal classifier, or for you to call your model as a best model, your precision as well as recall should ideally be 1. Then you can consider your model is at its best in its performance. That is how you are going to set your threshold to. That is, if your threshold is ranging from 0.5, ideally, if it is ranging till 0.8, both your precision and recall is 1. So that instead of going with defaults at threshold of 0.5, you can even go with 6, 7, and 8. But can you go beyond that? No, you cannot. Why? Because you can see beyond point 8, you can see a fall in your precision. See, your precision is dropping now. Now, what is the understanding of dropping in precision is? Precision is will be able to tell us how many true positives are there with the actual with the model prediction by considering the cluster of true positives and false positives. Till we have the higher precision, our true positives will be there. No, it will be predicted. It will be predicted correctly with the model. The moment your precision drops, model will keep on misclassifying the records. That is, your false positive rates will keep on increasing. That is what we need to make sure. We don't want true positives, not true negatives in our data. We always want true positives or true negatives higher in our data set. So for us to make the sure, our precision and recall should always be higher. That is an illustration that we can understand with the precision recall curve. Precision and recall plotted together, evaluated at the different threshold, will give us the understanding of model performance. Addition to this, you can even consider the area under your PR curve. That is, you're going to get a graph, you got a graph, something like this, right? You're going to consider the area under this PR curve. If the area under AUC, area under this PR curve, if it is higher, you can see the model performance is best. If this area is lower, you can see you have got a weak model. Typically, how do you evaluate it? The evaluation is done with the range of 0 to 1. So if your AUC value is nearer to 1, you can say your model performance is best. If it is nearer to 0, you can understand your model performance is weak. With this understanding, we are wrapping up our understanding of PR curve. Happy learning, all of you.